Problems involving complex summation technique I. This is the first video on the series of problems involving complex summation techniques. There are basically 5 videos where in each of them I will just see how to solve such sums where there is exponential and trigonometric functions using the complex numbers. So such functions basically become easier when we can express sine and cos in terms of e to the power I theta. Because we know that sine is just imaginary part, cos is the real part, and just real part is linear, and real part times and just real number is real number, imaginary part times real number is imaginary number. So those things are necessary that will help us solve this problem. So over here also n equals to 1 to n 2 to the power n, and we know that this is just real part of e to the power I n theta. Yes. Now in real part, even if we multiply the number by a real number, real part will be same, so we can take this inside. Again, real part is linear, so again we can take this outside the sum as well. So from that we see that we can take real part outside the sum, and sum from n equals to 1 to n of 2 to the power n e to the power I n theta. Yes. Now we have the real part of sum from n equals to 1 to n of 2 e to the power I theta to the power n. Yes. And now this is okay, so real part of, now we can sum this using geometric series. The first term is 2 e to the power I theta a, and r to the power n. R is just 2 e to the power I theta itself, and then our n is capital N minus 1 by r minus 1, 2 e to the power I theta minus 1. Yes. Now we have to find its real part. So in numerator, like we can just find real part, imaginary part, no problem. But if it's in denominator also, if there are both real part and imaginary part, we can do rationalization, but that will be a bit long. But so a way, and a nice trick is to, let's say, if we what we can do is we can multiply by the same number, but with the conjugate with the e expression. In the expression of e involving e, take the conjugate but the same expression. That means multiply by 2 e to the power minus I theta minus 1. This will convert the expression to either purely real or purely imaginary, and that will be helpful for us. Let's see if it does or not. Yes. Now in denominator, you can see that this is just 4 minus 2 to the power I theta minus 2 to the power minus I theta. So minus 2 e to the power I theta plus e to the power minus I theta, which is a purely real number, and the minus 1 is plus 1. So you see that purely real, so all of them is real. So that was the way. Now from numerator, just find the real part, and that can be the answer. So now let us see how we do that. Yes, over here. Okay, so over here, what we can do is we can just multiply like this. Now, if you multiply this 2 with this, that basically is 4 minus 2 e to the power I theta. Yes, 4 minus 2 e to the power I theta. Over here, that is 2 to the power n e to the power I n theta minus 1. Yes. Now this is the real part of, now over here this is 2 to the power n plus 2 e to the power I n theta minus 2 to the power n plus 1 e to the power I theta n plus 1. Is that yes, and then minus 4, now plus 2 to the power n plus 1 again, 2 to the power n plus 1, and that is so 4 to the power n plus 2 to the power I n theta minus this one is n plus 1. Now minus 4 and this is plus 2 to the power n plus 1 e to the power I theta. Okay, e to the power I theta by over here 5 minus 2 times 2 cos theta. Yes. Now let me cross check the results just in case if I'm doing any errors. Yeah. Let me cross check the results first before I share anything more with you. Yeah, that's always the nice thing to do. And I think there's slightly error. Oh, okay. I got a error. This is not okay. So just this is just plus 2, not to you. Not you. Okay, now I think that now it's completely correct. Just so now what we can do is to find the source over here. In denominator is already just a real part, so also find the real part from numerator as well. Yes, in numerator it is 2 to the power n plus 2, and this is cos of n theta. Yeah, and then minus 2 to the power n plus 1 cos of n plus 1 theta, and then yeah, minus 4 is this is also real part, plus 2 cos theta, and this should be our answer, though it's kind of long, but yeah, the answer is correct, I guess. Oh, wait a second. This is sine, that means it's imaginary part. Yes, not real part. Let me correct that. And this was his blunder, in fact. This was his blunder, but no, it doesn't matter. It doesn't matter. Okay. So at last, this should be the imaginary part. Yes, and if it's imaginary part, all of these cos change to sine. All of this cos change to sine, and there is no minus 4 because this is a purely real number, and this changes to sine. Okay, so now it should be correct. To the power n plus 2 to the power I n theta, n plus 2 sine n theta minus 2 to the power n plus 1 sine 1 theta plus 2 sine theta. Yes, now it's correct. Now this one is correct, and we are now good to proceed. Yes, now this is the answer. Let us just recap how we solved this. Yes, let us just recap. All of these are actually imaginary. Yes, imaginary. Okay, now good. So we first use sine theta as the imaginary part of e to the power n theta. The two exponential function which we combine, and then use the geometry sum formula, and then try to make the denominator just the real part, and then found the imaginary part from the numerator. Yeah, just here is just the real part, so find the imaginary part over here. That will just be imaginary part. Yeah, so that's why the eventual goal was met, and we got the answer, which is this thing. So that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.